Hey everyone, Alex Martin here, and it is another episode of Hey Sidewalk Scientist, brought to you from Sidewalk Science Center. Today joining me, because it's a space theme, we have Zero, who is the mascot for our star parties, which we host several times a week in public parks, and we let people see objects such as the moon. We had a great, fantastic showing of Jupiter and Saturn last year, the entire time that they were out, in the full 6 months that they were out during the evening. And now that Jupiter and Saturn are sadly gone and will not come back together for 20 years. Halloween 2040 can't come soon enough. We have some questions to answer about astronomy that we collected along the way. So today's question actually deals with the moon, which right now is just past its new phase here in the middle of February. That's when I'm filming this. The question is, how far is the moon from the sun? Now, this is a pretty good question, because when we think of the Earth, we think of the Earth being, a planet away from the sun. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Yes, it's Uranus. And then, of course, we have Pluto, which is way out there. It's the most beautiful object in the solar system, I think. But maybe less so known is the distance from the moon to the sun. Now, some of us might think of this, well, obviously the moon is going around the Earth, so it's the same distance away from the sun as the Earth is, which is kind of right, and also there's some room in there that we can work with to make this question happen. So how far away from the sun is the moon? Now, the Earth is of course 93.5 million miles away from the sun on average. The moon itself is, we have the moon right here. We have the moon in this, and why not use this as the Earth? So we have the moon, and the moon is going around the Earth. Now, the moon is not this close. The moon is not this close. If this is the Earth right here, the moon is 30 times this diameter away from the Earth, the Zero. So the moon is going really far, and then right in between, and then really far. On average, the moon is 240,000 miles away from the Earth. But the moon's orbit isn't circular. It's actually what is called an ellipse. So that is, the moon gets closer to the Earth and then farther away from the Earth, and then closer to the Earth and then farther away. So it varies from about 210,000 miles away from the Earth to somewhere around 260,000 miles away from the Earth. So this is also the reason, we're going to answer this in a different question, but this is also the reason why not all solar eclipses are total eclipses. Actually, one coming up in 2023 here in the United States that isn't a total eclipse. So because the moon's distance from the Earth varies from that about 210,000 to 260,000 range, that means that yes, the moon's distance from the sun is changing. The moon is sometimes closer to the sun during a new moon, sometimes farther away from the sun during a full moon. And then we of course have our two quarter moons, which we can say that right there, the moon is about the same distance away from the sun that the Earth is. So on the quarter moons, the moon is roughly the same distance, is roughly on average 93.5 million miles away. So to calculate the distance of the moon from the sun when it is a new moon, we have to take roughly 93.5 million and subtract 240,000. So that brings us to about 93.25 million miles away when it's closest to the sun. But then you have to do the exact opposite when it's a full moon, and you have to add that 240,000 miles when it's a full moon. So that 93.5 million becomes 93.75 million miles away from the sun. So yes, the moon is constantly changing its distance from the sun. It's actually about every 29.3 days that the moon is at new and then at full 2 weeks later. So that 29.3 day cycle, it's sometimes closer and it's sometimes farther. And then sometimes it's the same distance as the Earth. So yes, even though that question might seem silly at first, there is a legitimate answer, and it's an ever-changing answer. And that's just what's so cool about the solar system, is that it's an ever-changing body of objects. It's not static. You can look at Jupiter through a telescope, and you can actually watch the moons of Jupiter orbit it. Sit there for an hour, 2 hours, 3 hours, you can see them moving. It's not just something that's standing still out there. We can perceive this with our own eyes. So if you have a telescope, or if you have binoculars, or some way just to look up at the stars, or whatever you're curious about, whatever you want to imagine. Because there's these little tidbits of information that you might not see at first, but as you dive deeper into them, you realize that yes, there is an answer, but it's not always going to be a simple one, and it won't always be a complex one. You just have to keep on looking. And the important part is that you are doing that research and you are thinking about it in this whole other way. Zaro and I want to give a big shout out to all of our $5 patrons right up here in the corner, and to all of our other patrons who make Sidewalk Science Center and videos like these possible every single month. If you would like to support our programs, you can go on over to patreon.com/ExperienceDeLeona, where you can support us for as little as $1 per month. And for every $5 pledge, we will donate a free science kit to a participant at Sidewalk Science Center. Thank you guys, and we'll see you next time. When those two meet, that's your bolt of lightning. That is called a stroke, a lightning stroke. That's the thick part of the lightning that makes its way down to the ground. That's when you get your flash of lightning. And then soon after that, you get your rumble of thunder as that shock wave from the attraction